for more than 2 decades. The Chevrolet 5.3-liter V8 has been one of the most widely used truck and SUV engines in North America. Installed in millions of vehicles from half-ton pickups to full-size SUVs, earned a reputation for smooth power delivery, respectable fuel economy for a V8, and long-term durability. But in recent years, that reputation has been seriously tested. Owners, technicians, and engineers began pointing to a pattern of recurring mechanical failures that, if left unresolved, often led to catastrophic engine damage. By 2026, however, a critical series of engineering changes emerged that fundamentally altered the long-term outlook of the 5.3 liters V8. This was not a cosmetic refresh or a marketing tweak. It was a structural, mechanical fix one that directly targeted the root causes of failure and, according to powertrain experts, may finally future-proof one of GM's most important engines. This video breaks down what went wrong, why earlier updates weren't enough, and how the 2026 redesign reshapes the reliability story of the Chevy 5.3 LV8. The modern 5.3 LV8, part of GM's EcoTech 3 family, evolved significantly from the simpler Gen 3 and Gen 4 small block engines. As efficiency and emissions regulations tightened, GM introduced advanced technologies such as active fuel management AF and later dynamic fuel management. These systems allowed the engine to deactivate cylinders during light load driving, improving fuel economy. On paper, the concept was brilliant. In practice, it introduced a critical weak link into an otherwise robust engine architecture. At the center of the reliability debate was the Valvetran, specifically the AFM and DFM lifters. These specialized hydraulic lifters rely on internal locking pins and precise oil pressure to switch between active and deactivated modes. Over time, several problems emerged. Oil pressure instability caused lifters to partially collapse. Contaminated oil accelerated internal or heat cycling weakened lifter components, especially during towing or heavy use. When a lifter failed, it often took the camshaft with it. Metal debris then circulated through the engine, damaging bearings and oil passages. In many cases, the result wasn't repair, it was full engine replacement. Powertrain teardown specialists frequently describe these engines as mechanically sound everywhere except the lifters, which made the failures especially frustrating. Before 2026, GM introduced incremental updates intended to reduce failure rates. These included revised oil deflectors, updated lifter part numbers, software recalibrations to reduce cylinder deactivation frequency. While these changes helped, they treated symptoms rather than root causes. Independent engine builders and dealership master technicians noticed a consistent pattern. Even with updated parts, the fundamental lifter architecture remained unchanged. The engine still depended on extremely tight tolerances, flawless oil quality, and ideal driving conditions to survive long-term. As one veteran GM technician put it, we saw engines fail at 40,000 miles and others go past 200,000. The difference wasn't luck, it was whether the lifters stayed perfectly happy. And that's not something owners can control. The 2026 update represents a true system-level fix, not a single upgraded component. GM engineers focused on one critical question: how do we keep the 5.3 V8 alive when real-world conditions aren't perfect? The answer came in 3 major areas. The most important change for 2026 is an entirely new lifter architecture. Unlike previous revisions that focused on materials or coatings, this redesign rethinks how the lifter functions internally. Key changes include a simplified locking mechanism with fewer moving parts, wider oil passages to reduce sensitivity to minor contamination, improved metallurgy to handle sustained heat and load. Engine development engineers note that the new lifters are far less dependent on perfect oil pressure at every moment. Brief pressure drops that once caused damage are now tolerated without catastrophic consequences. According to engineers familiar with GM's validation testing, the new lifters were subjected to endurance cycles simulating poor maintenance, heavy towing, and extended idling conditions that previously exposed major weaknesses. Lifter failures were never just about the lifters themselves. Oil delivery and pressure stability played an equally important role. For 2026, GM implemented several oil system improvements, revised oil pump calibration for more consistent pressure at low RPM, improved oil routing to the lifter valley, reducing pressure lag during reactivation, enhanced filtration strategies that captured debris earlier in the oil's life cycle. Lubrication specialists emphasize that these changes work together. The goal isn't higher oil pressure, it's stable oil pressure. As one engineer explained, most engines don't die from lack of oil. They die from inconsistent oil, Rather than eliminating cylinder deactivation entirely, GM refined how and when it operates. The 2026 control strategy is more conservative, fewer rapid transitions between modes, reduced deactivation under borderline conditions such as light towing, hilly terrain, or thermal stress from an engineering standpoint. This reduces mechanical shock in the valvetrain and limits unnecessary lifter movement to major contributors to where, importantly, the system still delivers fuel efficiency benefits, but no longer at the expense of long-term durability. The real difference lies in validation depth. Multiple engine builders report that GM dramatically expanded durability testing, including teardown analysis after extended abuse cycles. Unlike previous generations where lifters often showed early wear, the 2026 components reportedly maintained their geometry and surface finish far longer. One independent engine remanufacturer who reviewed early teardown units stated, "This is the first time in years we've opened a modern 5.3 and not immediately zeroed in on the lifters as a future failure point." That comment carries serious weight in the rebuilding community. For owners, the 2026 fix represents more than peace of mind. It changes expectations. Reduced risk of catastrophic failure. Failures are now more likely to be gradual and detectable rather than sudden and terminal. More predictable longevity. The gap between bulletproof and fragile engines has narrowed significantly. Improved suitability for towing and heavy use. Fleet operators and contractors stand to benefit the most. For years, enthusiasts turned to aftermarket AFM and DFM delete kits as a reliability solution. While effective, they came with trade-offs. Emissions compliance issues, check engine lights, voided warranties. The 2026 redesign offers a factory-engineered alternative that retains efficiency without sacrificing durability. For the first time, deleting cylinder deactivation may no longer be the default recommendation. The 5.3 LV8 isn't just another engine, it's the backbone of GM's truck lineup. Lessons learned here directly influence the 6.2 LV8 and future small block designs. Industry analysts see the 2026 changes as a philosophical shift inside GM. Durability is once again taking priority over marginal efficiency gains. That matters not just mechanically, but for brand trust. Based on engineering changes, expert teardown analysis, and early durability data, the answer appears to be yes. The 2026 fix doesn't rely on hope, software tricks, or minor part revisions. It directly addresses the core mechanical weaknesses that once put the Chevy 5.3 LV8 at risk of self-destruction. By stabilizing oil delivery, redesigning the lifters, and refining cylinder deactivation logic, GM has transformed a vulnerable system into a far more resilient one. For an engine that powers millions of vehicles and represents decades of V8 heritage, this isn't just an update, it's a necessary course correction. If history judges the modern small block V8 fairly, 2026 may be remembered as the year the 5.3 finally got the engineering solution it always needed.